Hey everyone, and welcome. As a curious science explorer, I am absolutely thrilled to guide you through this explainer today. We're not just doing a boring review for your upcoming middle school science exam. Nope, we are actually taking an incredible journey across India. We'll be traveling alongside two young explorers, Molly and Vali, as they visit family. And along the way, we're going to discover how the exact scientific principles you need to know for your test are being used every single day right in their relatives' kitchens and fields. It's going to be fun, so let's get started. Okay, let's dive right into this by anchoring our scientific journey in history. The ancient poet Kabir actually bridges our rich cultural heritage with our very first scientific concept. He compares the wisdom of sages who hold on to good virtues and let go of vices to the physical process of separating grains from their husks. It's beautiful poetry, but you know what? It's also pure science. So here's our study guide map for today. We'll cover 1. Exploring India's methods. 2. Size, salt, and history. 3. Tea time science. 4. Magnets and industry. 5. The ultimate mixture challenge. And finally, 6. A final study checklist.
Section 1. Exploring India's methods.
Let's start our journey in the bright, sunny fields of Haryana. Molly and Vali have just arrived at their Nani's house, and they immediately see their family hard at work preparing the harvest. The first method they encounter is right there in Nani's kitchen. She's making this steaming hot, delicious vegetable pulao, and to prep the ingredients, she uses hand-picking. Hand-picking is a straightforward method that actually, scratch that, it relies entirely on visual differences. Because small stones look different in size, color, and shape from the grains of rice, Nani can easily just pick them out by hand. It's super simple, but highly effective for preparing healthy food in small quantities. Moving outside to the fields, the kids watch their mama and other farmers performing our next method, threshing. The farmers are literally beating harvested wheat stalks against large wooden logs to break the useful grains free from the stalks. And what's really wonderful here is that they sing these rhythmic folk songs as they work. It turns a physically demanding, exhausting process into this shared communal joy. But wait, the grain is still mixed with the light, papery husk. So how do they separate that? Well, this brilliantly illustrates winnowing. A farmer stands on a raised platform, shaking a bamboo tray filled with the threshed mixture. As it falls, the wind pushes the lighter husks far away, while the heavier wheat grains fall straight down into a nice, clean pile. The scientific principle at play here is density and weight. The wind easily carries that lighter material, perfectly separating it from the heavy, valuable grain. Section 2. Size, salt, and history. Next up, our journey takes us west to Ahmedabad, where Molly and Vali learn how the specific physical properties of matter dictate exactly which separation method we have to use. For example, when their mommy prepares meaty puri, she uses sieving. Why? Because the scientific property at play here is particle size. The fine wheat flour passes right through the tiny holes of the sieve, while the larger, bulky bran gets trapped on top. But think about this. What if a solid is completely dissolved in a liquid, like salt in water? You obviously can't sieve that, right? You have to rely on a phase change, specifically evaporation, to boil the liquid away and leave the solid behind. Let's trace evaporation through time for a second, because it's a technique that has literally shaped India's history. In ancient times, Ayurvedic practitioners used slow evaporation by drying medicinal herbs in the shade. This carefully removed water while preserving the delicate healing properties to create natural Ayurvedic medicines. Fast forward to 1930, and Mahatma Gandhi famously used the evaporation of seawater to harvest salt during the historic Dandi March, protesting unjust laws. And today, we still use massive shallow pits exposed to the sun and air to evaporate seawater and harvest the very salt we eat. Now, before we go any further, I need to give you a quick but absolutely critical safety warning for your upcoming labs. When you practice evaporation in your middle school science classroom, you'll be handling hazardous heat sources. Always place your china dish on a wire gauze, heated carefully over a spirit lamp, and most importantly, allow your tools to cool completely before you touch them or put them away in proper storage, especially when dealing with hazardous chemicals or sharp laboratory tools. Safety is step 1 of any scientific experiment, guys. Section 3. Tea time science. Now, let's head south to Puducherry. Molly and Vali are visiting their Dada and Dadi. It's tea time, which actually turns out to be the perfect opportunity to unlock the secrets of separating solids from liquids. And pay attention here, because this concept clears up a very common exam trip-up. When Dada makes tea, he lets the pot sit undisturbed so the heavier tea leaves sink to the bottom. That process of settling is called sedimentation. Then he carefully pours the clear tea into a cup without disturbing the leaves. That careful pouring action, that's decantation. Two distinct steps, two distinct scientific terms. Don't mix them up on the test.
Okay, pop quiz time. Let's test your knowledge right now. Based on what we just talked about, if you have a liquid mixture of oil and water, how do you separate them? Think about their physical properties. Oil is lighter than water and it doesn't mix with it, so what does it do? It floats. You simply let it settle into two layers. Yep, that's sedimentation. And then you use decantation to gently pour that floating oil right off the top.
Let's see how this builds into an even more precise method, filtration. Dada notices that decantation might still let a few stray tea leaves slip through, so he uses a fine strainer. This practice actually traces all the way back to ancient textile traditions, where woven cloth with small pores was used as an early filter. Later on, in the early modern era, people used soft silk or muslin for early tea bags. Today, we use highly engineered fine pore filter paper, which is absolutely essential for modern water purification efforts globally. In fact, you can see filtration in action by building a home project, just like Valley did when she collected muddy pond water on her nature walk. It's super cool. If you layer different pore sizes, like cotton at the bottom, then charcoal, then sand, and pour muddy water through it, those layers act as a series of physical traps. The mud is trapped as the residue, and clean water drips out at the bottom as the filtrate. It's a fantastic, low-cost way to build a simple water filtration model right in your kitchen. Speaking of water, while on a boat ride, Molly and Volley are shocked to see a fishing net acting as a giant, unintended filter, catching not just fish, but plastic bags and wrappers. The tragic poem here about Colis the fish is a heartbreaking reminder. Protecting our rivers from plastic pollution isn't just about keeping the water looking nice. It is absolutely vital for aquatic life safety. Our modern filtration techniques are great, but they can only do so much. We literally must stop pollution at the source.
Section 4. Magnets and Industry. For the final legs of their journey, the children travel to a roadside eatery in Madhya Pradesh and then up to a carpenter's shop in Meghalaya. Here, we see how separation methods scale from tiny tasks to huge global industries. At the eatery, they see churning. A wooden churner physically agitates curd, and because butter is less dense, it floats to the top of the buttermilk. But in Meghalaya, a carpenter accidentally drops a box of iron nails into a massive pile of sawdust. He doesn't churn it, and he sure doesn't handpick it. He uses a magnet. Magnetic separation relies purely on the magnetic property of the iron, pulling those nails instantly out of the non-magnetic sawdust.
And if you imagine scaling that up, the exact same principle the carpenter used is running massive industries. Huge recycling plants use heavy-duty cranes equipped with giant electromagnets. They sweep over enormous mountains of trash, instantly pulling out thousands of pounds of scrap iron from waste volumes to be recycled. It just proves that the scientific principles you learn in a middle school classroom are the exact same ones running our modern world.
Section 5. The Ultimate Mixture Challenge.
All right, focus learners, you've traveled across India, you've seen the methods, and you know the physical properties. You are now ready for the Mastery Challenge, a complex multi-step guide guaranteed to show up on your final science exam. Imagine you're handed a beaker mixed with iron filings, sand, and salt. How do you untangle that? The crucial point is following this exact sequence. Step 1, sweep a magnet over it to remove the magnetic iron. Step 2, add water. The salt dissolves, but the sand doesn't. Step 3, pour the mixture through filter paper. The sand gets trapped as residue, and the salty water passes through as filtrate. Step 4, gently heat that filtrate to evaporate the water, leaving pure salt behind. Magnetism, solubility, particle size, and a phase change, all working perfectly together.
Section 6. Final Study Checklist.
As Mali and Volley's journey beautifully concludes, here is your definitive study checklist. I highly recommend grabbing a screenshot of this to review later. To totally ace your test, you have to be able to match the separation method to its underlying scientific property. Remember, handpicking for visual size and color, winnowing for wind and weight differences, sieving and filtration for particle sizes, and evaporation for phase changes. And remember how these techniques aren't just textbook vocabulary. They help us prepare healthy food, create natural Ayurvedic medicines, purify our drinking water, and recycle our waste. I'm going to leave you with one final provocative thought to ponder. If you were stranded in the wilderness with just basic supplies, how would you combine sedimentation, filtration, and evaporation to create safe, clean drinking water for your survival? Think through the steps we discussed today. You have the knowledge now. Until next time, keep exploring the incredible science hidden right in your everyday life.